Hi everyone, today's video is about preparing to solve systems of equations. There's a few things I'd like you to recall: that linear equations are equations in two variables, where the variables are in the first degree. Y equals 3x plus 7 is a linear equation because x is to the first power and y is to the first power. The solutions to a linear equation are the sets of coordinate pairs that look like this, values of x and y, related values, that make the equation true. The graph of a linear equation is a line that's made up of all these sets, x and y, that make the equation true. For example, the linear equation I noted above, if x was 2, y would be 13. This is a true solution to the linear equation that's given, and that point would be sitting on the line. So the true solutions to a linear equation are all the points that are on the graph of the equation. The first technique I want to review is writing the equation of a given graph. So here's a sketch of a graph where I have a line drawn, and I need you to write the equation for this line. So in order to do this, I need to identify what my slope is and what my y-intercept is. Well, my y-intercept is pretty easy. I can see it right there on the line. And my slope, if I count from one point to the other, is up 1, 2, 3, 4, and over 1, 2, 3, 4, 5. So my slope is 4/5. So to write the equation of this line, y equals mx plus b, I would just substitute in these two values. Y equals 4/5 x minus 2. Our next technique is writing the equation of a line running through the given points in point-slope form. So using the points, I've already calculated my slope of -2. I'm going to choose one of the points. I'll use 212, and I'm going to just substitute it in to my point-slope form, which is right here at the top of the page. So y minus 12 equals -2 times x minus, whoops, let me get rid of that. It should be x minus 2, parentheses, and you're done. The next step is to take the point-slope equation that you made and convert it to slope-intercept form and then to standard form. So I'm going to simplify -2x plus 4. I'm going to convert this to slope-intercept, and then I'm going to convert this to standard. So my standard form is 2x plus y equals 16. Slope-intercept is y equals mx plus b, and standard form ax plus by equals c. We want to graph the equation of -3x, y equals -3x plus. A quick review of graphing techniques. I'd like you to graph the equation y equals -3x plus 4 using the slope-intercept form. So we need to identify in this equation that the slope is -3 and the intercept is positive 4. So I'm going to plot the point on my intercept. 1, 2, 3, 4. Here's my point. And then I'm going to use my slope to count down. I'm going to try and make this a little fatter. So I'm going to count down 1, 2, 3, and over 1, 1, 2, 3, and over 1. Connecting the points. Ooh, there's my graph. The next technique is graphing the equation using the two intercepts. The intercepts are the point at which the lines cross each of the axes. We find those by setting x to 0 to find the y-axis. So y equals 3. So when x is 0, y will be 3. And then we set y to 0 and calculate the x-intercept, 2/3, 2/3. I'm kind of speeding through it because I'm pretty sure you guys know how to do this. So when y is 0, x is -2. So 0, -2, and -2, 0, and 0, 3 give us our two intercepts, and we draw the line through. This is probably the quickest way for you to do a graph. The last idea is a new idea that not new in math, but new to us, eliminating decimals by multiplying by powers of 10. So the idea is, as you know, and we've worked with decimals before, that multiplying by powers of 10 allows us to shift the decimal point around. Like when we were doing percents, we use that technique, okay? So the idea is, sometimes when we're working with systems, it's easier to have the whole number. So I would like to get these decimal numbers to look like whole numbers. And so what I'm going to do is look at how many places are behind the decimal point. In this particular one, there's only one place behind all of them. So I'm going to multiply both sides of the equation by 10, which I can do because so long as I do the same thing to both sides, I'm not changing the value of the equation. So by doing that, I end up with all whole number coefficients. 43x plus 27y equals -98. The other case is when we have varied numbers or more numbers behind the decimal point. So what do we do in this case? What we're actually doing is looking for the biggest number of digits behind the decimal point. In this case, it's 1.578. There's 3 places behind the decimal. I'm going to multiply by 10 to the 3rd power, or 1000, right? The 3rd power comes from these 3 places, and that says move my decimal point 3 places to the right. So I end up with 8,760x plus 2,300y equals 1,578. Okay, I know this was a long one, but that's it for now.